Hello everybody, Mr. Montaigne here, sitting on my bed, recording from home, obviously, and here's our next installment of videos, well I guess just the next video, which is going to be how to find the volume of a cylinder. So we already went over how to find the volume of a rectangular prism and a triangular prism, which was really nice because they were both kind of connected, length times width times height, or base times height times length, divided by 2. That was the second one there was for a triangular prism. And now we're going to go into the volume of a cylinder. So here I already have everything set up, okay? So finding the volume of a cylinder is just as fun and amazing as the volume of a rectangular or triangular prism. Now I'm comparing this to finding the surface area of rectangular prism, triangular prism, and cylinder, or any other three-dimensional object, but also just in general, it's awesome. So, there's one formula that we're going to be using. If you find another formula for the cylinder that you're using, just remember those steps when we're working through questions that you need to have, so that I can see the formula you're using before you substitute any value into it. Otherwise, I won't know what's going on, and I won't be able to follow and give you recognition when you deserve it. So, the things you need to know: R is going to be radius, H is going to be height, and pi that I'm going to use for these questions is 3.14. Now, we're doing this for grade 8s, right? If you're going grade 9, you might want to use the pi button on your calculator. If you are just a little bit off because you are using the pi button on your calculator, that's fine. It's okay. There are just minor differences, okay? So anyways, so you might also see it as the volume of a cylinder is the A times H, where A is actually, if you're looking at some sort of cylinder like this, not very good, A is going to be the area of the top or the bottom, so the circle, which is pi r squared. So if you see the difference here, V equals AH, V equals pi r squared H. So the A and the pi r squared, you could kind of change whenever you need. Let's go right into an example. I'm going to go over 2 examples in this video. So the first one is a very, very tiny example. Literally, it's a dime. So example 1 is, what is the volume of of metal that is needed for a dime? So this is, if you're working at the mint, this is something that you'll need to know, right? If you're going to be purchasing nickel to make these, then I think they're made of nickel. They're not silver anymore, that's for sure. They might maybe nickel plated, brass. There's some metal in there. Anyways, so before you could go ahead and make it, you need to find out, well, what amount do you need to purchase and how much are you going to get from it? So, well, how much metal do you need for 1 dime? And to do that, we find its volume. So I have a picture of a dime here, not a very well put up lines or anything like that, because it just is what it is. Oh well. So I have the diameter is equal to 11.03 millimeters, and the height is 1.22 millimeters. So you almost can't even see it. This is a top-down view, unfortunately. It's hard to find a picture of a dime on the side so you can see the width. But if you find one, send it to me so I could have it for future math. So you might remember from finding the volume of triangular prisms and rectangular prisms that there's kind of a certain amount of steps that we are going to take. Now they are the same steps even for a cylinder. The only difference is the formula that we're going to use is a little bit different. So here are the steps, or what's called the algorithm, of what you need to do for each volume question. So first is determine the shape you're dealing with. Well, this is going to be a cylinder. Obviously, it's a super, super awkward shaped cylinder because it's kind of really wide, takes up a lot of area, and its width or height is like tiny, tiny, tiny. Squish your head, squish your head. Anyways, and so it's a cylinder. Next is write out the formula you're going to use. So I'm going to be using the formula that I used, or that I wrote up top here. So I have my volume is equal to pi r squared h. And then finally, kind of write out what you know. So 2 and 3, if you like, you can switch them. You could do those two in any order. But I'm writing this down first because I see here that I have a radius. I don't have height. So the easiest thing to do is actually to find the radius. It's just half the diameter. So my radius is my diameter divided by 2, which is 18.03 millimeters divided by 2 equals 9.015. Okay, so now I know what my radius is. And I needed that to use this formula. You can try to use a formula with diameter, but it gets a little bit messy because it's going to be, I'm not even going to go into it. If you'd like to use it, you could look it up. Next thing I need to do is I'm on number 4, substitute your values in. So in this case, my volume, so pi, well, I'm going to use it as 3.14. And my radius, I found to be 9.015 millimeters. And my height, oh, sorry, that is squared as well. Forgot that. And then I have my height, which is 1.22 millimeters. So I have my fourth step, everything's substituted in, so that pi I know is 3.14, radius is 9.015, and we could keep going through it. So, oh, looks like I didn't leave enough space underneath, but that's okay. So now I'm going to go ahead and I use the order of operations to solve this. So brackets, or BEDMAS, right? Or PEMDAS. Both mean the same thing. Okay, so B is brackets. I do have brackets, but there's only one number in it, so I don't need to worry about it. E for exponents. Yes, I have to do that. So I'm going to do that first. So the 3.14 stays the same. And that 1.22 millimeters also stays the same. And then we could go ahead and find out what our answer, or question, what our answer is. So I have 9.015 times 9.015 equals, so there we have it. We have the 9.015 squared is going to be 81. Grab this. 81.27 millimeters squared. All right. So now that we have the squared out of the way, we can go ahead and keep going through our order of operations. So we have brackets done, exponents done, no division, and looking at multiplication. And look at that, we have 3 things that we're multiplying. And so there we have it. It's going to be 311.33 millimeters squared. Or sorry, cubed. There we go. So there we have it. So I went through this question again. It's going to be the same order that finding the volume of a rectangular prism or triangular prism is. Follow the exact same steps every time. Now, I don't know if you caught this, but I just caught myself. I'm not actually done here. And the reason I'm not done is this is a word problem. So I need a word answer. So let me finish that up. So my question here was, what volume of metal is needed to make a dime? I'm just going to circle it for good luck. There we go. And there's our question. Okay. So I have one more example for you. I'm going to go through it pretty quickly. Example 2. So a grain silo is about 21.6 meters tall and has a radius of 5.25. How much grain can the silo hold? And believe it or not, farmers actually do this to find out how much grain they have in their silo. So it's a much easier way than having to actually take it out. It's just know the measurements of the silo. And so you measure the radius of it, which they would have already, and they measure the depth at which how much grain or whatever product they have, and then they calculate the volume. And it actually tells them roughly, very well, I guess pretty accurately, how much they have. So this is grain. So if I'm going through this one, first thing, well, I have to decide what shape is this. Well, I'm looking at the picture here in a silo, and it's a cylinder, so it's a cylinder. So I know that I'm going to have, my volume is pi r squared h. So now I'm going to read the game again, and remember this is to be... Alright, so I'm going to go ahead and read the question again, and I'm going to underline anything that's important. So grain silo is about 21.6 meters tall. I'd say 21.6 meters tall is pretty important. It has a radius of 5.25. How much grain can the silo hold? Alright. So I have the height. So the height is not going to be the dome part. And we're going to say the height is 5.25. No, it's not. It's 21.6. And then I also have the radius. You can't really tell from this one. It would look like that. So the radius is 5.25 meters. All right, so I'm writing down what I know. My equation has radius and height. I have those two things, so I can actually go ahead and substitute my values into it, my formula already. So volume is equal to pi, which is 3.14. My radius, which is 5.25 meters squared on the outside. And then I also have my height, that is 21.6 meters. That's all substituted. Now I'm going to use the order of operations to solve. Now, whenever we're working with volume for rectangular or for cylinders, we're always going to do this squared part first. Okay, and everything else stays the same. So 3.14. Here I'm just going to put 5.25 times 5.25. And it equals 27.56 meters squared. And then finally we have our height. Nothing happened to it. 21.6 meters not squared, just meters. Continue with our order of operations, and as we go through it, it's just going to be multiplying these three things here. Okay, so again, I'm not going to write it out here, I'm just going to type it, because OneNote will calculate it for me. So 3.14 times, which is just the x, 27.56 times 21.6. So I'm not leaving any spaces, then the equal, then I press space. It didn't calculate it. There we go. And so I have 1,869 and round it up to the second decimal place, which I forgot. It should be 0.23. There we go. And now the units. So I have meters, and since it is volume, it has to be cubed. And if we think about this and we go back, right over here we have 5.25 meters. But when we square it, we have meter times a meter, which gives us 2 meters, so meter squared. Then another meter, so there's 3 of them in total. So that's where that 3 comes from, the 3 dimensions. And there we go. So again, this is a word problem. So before I can go and say that I'm actually done, I need to write that word answer. And it's really important that you do that, especially for word problems, right? Because if you just did some calculations for a farmer, we'll say for this question, you're like, here's a number. They won't have any idea what that means. Mostly because you're not communicating that. And so sometimes you'll be able to just talk and tell somebody what it is, but maybe in this situation, you're working with other people and you need to leave a note for somebody later on. So we can say the grain silo can hold about 1,869.23 meters squared, or meters cubed. Of grain. And there we go. So the really important thing with these word answers is they don't need to be a lot. It kind of needs to explain what the number is and what it represents, so that when somebody is looking at your work, they know what it's for. Okay? And that is the whole purpose of it. So in mathematics, you are actually communicating your work and what you're doing. So make sure that you take time for that. And then finally, let's circle my answer. All right. So that's it for this video. I hope you found it helpful. If you do have any questions, please feel free to email me or message me on Teams, and I'll try to help you out as soon as I can. Thanks. See you, everybody.